Cool. Hello, my name is Chloe Avery. I'm going to be talking about DePINs today. So I am a mathematician by training. I have a PhD from the University of Chicago, and my thesis was actually in geometry topology, so essentially shapes. And really, all that I used for my research was a pencil and paper, or a chalkboard. So when I first stepped into the world of Web3, it was just a few years ago, and I had no idea what I was getting into. But I knew that there were a ton of really, really interesting problems in the space. And to be a good mathematician is to be good at solving puzzles. So that's what I started doing when I started working for Orchid. And I have to admit, I'm one of those people who got into TikTok during the early days of the pandemic. I was hesitant for a while, but my sister, who is solidly Gen Z, insisted that I try it. I'm not that much of a social media person. I don't post often. I forget to like or comment on things that my actual real life friends post. But I do really like watching funny videos. And TikTok quickly learned my particular sense of humor. I have 2 dogs, and TikTok started showing me all of these videos of dogs that look just like the dogs that I have. TikTok really seems to know me. The algorithm knows me. And as someone who works in Web3, I'm maybe a little bit ashamed to admit this, but I love it. I love that TikTok knows me. I love these very personal suggestions. But I feel like I should know better. And this really makes me think. As AI becomes more and more, oh, sorry. What have I done? I am so sorry. Hold on. There we go. Okay. As AI becomes more and more a part of our daily lives, AI is also going to know me. And probably even better than something like TikTok knows me. Even if I'm not the one using AI, think about how much you can find out about me from the people around me. AI is going to know me. Is this a bad thing? I don't know. Honestly, I mean, there are probably amazing things that we could do using the fact that AI is going to know me. But I don't know, maybe this is also scary. If this gets in the hand of one person, that is a lot of information that they are going to have about me. And information is power. That's terrifying. So, what do we do about it? Decentralization. And today I want to talk specifically about decentralized physical infrastructure. The term DePIN has recently become this hot topic in Web3. And as people who work in the Web3 space, we love the word decentralized. We love to put it in front of everything. But why decentralized physical infrastructure? Why this specifically? I mean, I really think that DePINs have a compelling narrative. We're taking these principles of decentralization and we're taking them to the physical machines that power the internet. Storage, compute, bandwidth, etc., all incentivized and paid for using crypto. Here are a couple of examples from the company I work for, which is Orchid. Orchid has two projects. The first is a VPN marketplace. So the VPN marketplace allows bandwidth providers to store tokens, or to stake tokens to advertise their service in the Orchid directory. It's an Ethereum smart contract. Providers then receive a proportionate amount of clients. This is using something called stake-weighted random selection. When a client is connected to a provider, they can start providing service by the packet. If a client receives, they can start paying for service by the packet. If a client receives bad service, then they can simply just switch to a different provider. This is in contrast to a traditional VPN service where users are expected to subscribe and then maybe pay a monthly fee. Users in a traditional VPN have to trust that the provider is actually going to provide good service. Whereas with something like a decentralized VPN, if the provider starts providing bad service, you can just switch to a different provider. And actually, the ability for a user to switch to a different provider incentivizes the provider to provide good service. The other project that we have is Storkid. So storage Orchid, Storkid. This is decentralized data storage. And actually, we're currently building this. If you're interested in thinking about this kind of stuff, please come talk to me. I'd be happy to. So the idea for this is rather than store your data with a single company, that's a single point of failure, and you're putting trust in this company. The idea here is instead of that, you could break up your file into a bunch of different pieces and send each of those pieces to a different storage provider. When you break it up, you do this in sort of a redundant fashion, so that if you lose one or more of the pieces, you're still going to be fine. Actually, I mentioned that I'm a mathematician. There's a lot of really cool math that goes into exactly how you break up the files. If you want to learn more about that, please come talk to me. I love talking about cool math things. Yeah, so you break up these files, and if you lose one, we're able to repair that storage provider. The other providers in the cohort can pick a new provider for you. They can send them the data that they need. So this is the idea of decentralized data storage. These are a couple of examples of this decentralized physical infrastructure. And one of the technologies that both of these use is something called nanopayments. So I mentioned before the idea of trust. If you're using these decentralized physical infrastructures, you don't want to have to trust providers. These are maybe random people. So suppose that you're a provider that I do not trust, and I want to pay you for a service. Say maybe it's bandwidth. Well, I certainly don't trust you with $10. I probably don't even trust you with $1. But maybe if I sent you a fraction of a penny, well, if I lose that, if you screw me over, fine, okay, I've lost a fraction of a penny, I will be okay. So how do I send you these like tiny amounts of money? Because if you think about traditional payment systems, there's usually a minimum amount that you have to send and some sort of transaction fee. So how do we do this? Say I wanted to send you a penny. Well, instead of sending you a penny, what I'm going to do is I'm going to send you a 1 in 100 chance of getting $1. So if I do this over and over and over again, you're going to get the same amount of money that you would have expected if I had sent you pennies. And like I said, you can do this with fractions of pennies. You can do this with tiny, tiny amounts of money. And the main principle that makes this work is something called the law of large numbers. It says that if you repeat a probability theorem enough times, a large number of times, that you're going to get the expected value. So I guess why NanoPay for decentralized physical infrastructure? That idea really goes back to trust. Yeah, I mentioned this before, but you don't want to trust these people that you're just randomly finding on the internet. So there's actually one more really interesting example that I want to talk about for NanoPay, which is using nanopayments to pay for generative AI. There's this little demo that somebody else from Orchid, Dan Montgomery, has been working on. So the idea is that rather than pay for a subscription, say something like ChatGPT, I don't actually know how much it is a month. I think it's like, I don't know, it's quite expensive. So rather than paying for something like that, you could just buy the question you ask ChatGPT. You could pay these tiny, tiny amounts of money, and you can use NanoPay for it. So this is just another interesting example of how we could use nanopayments. If you're interested in this, here's the link right here. And yeah, I mean, I'm really excited about decentralized physical infrastructure. I think this idea of using these principles of decentralization to power these sort of basic things that we use to get the internet services that we use every day is really, really compelling to me. If you want to learn more about any of this, please do come talk to me. If you want to talk about the cool math, please come talk to me. That QR code is the link to our website. There's my info. Thank you so much.
Everybody give it up for Dr. Avery. Wow, I messed that up. Everybody give it up for Dr. Chloe Avery. All right, our next speaker will be